Hello everyone, this is Vignesh along with my teammates Vaishnavi, Rajat and Tejaswini from Team 1 N Division are here to present our project which we have decided to name it as Pong Launcher. We have proceeded with our project under the guidance of our Radhika ma'am. So here we begin.
Problem definition. In our need statement, we have found some of objectives, constraints, and functions. Some objectives are: what task should the project perform, what is the purpose of this model, and so on. Some constraints are: how many days would be required to complete this model, how much space would the model occupy, and so on. Some functions are: should the launcher be loaded manually or automatically? Do you want the number of balls to be counted or not? And so on. By all of these functions, constraints, objectives, we have defined our problem definition. The project is stationary ball launcher mainly for entertainment of kids and pets. The project mainly aims to shoot one ping pong ball at a time, automatically when inserted, at a speed of 1 meter per second for a range of 2 to 3 meters. The machine has been planned to be ready in a span of 55 days, occupying 1.5 cubic feet volume not exceeding a budget of 3500 rupees. Also aiming to have alert display system indicating when ball is shot. Function tree and function clustering. Function tree. In ball launcher, handling of the ball till launcher, launching the ball are main two functions. In handling of a ball till the launcher has some subsystems. Those are: indication that machine is on or off, ball insertion, ball is carried through a passage, ball is set before the launcher. In launching the ball, we have some more sub functions. Ball is loaded on the launcher, ball is launched when placed on it, indication that ball is ready for launch, and launcher is reset for the next launch. Function clustering. In ball launcher, we have clustered our main two functions into two clusters: handling of the ball till the launcher and launching the ball. Indication, insertion, ball is carried through passage, ball is set before the launcher, all comes into handling of the ball till the launcher cluster. Ball is loaded on the launcher, ball is launched when placed on it. Indication, the launcher is reset for the next launch. All comes into launching the ball clustering. By all of this, we have identified our main two subsystems. Those are holding unit and launching unit.
And now coming to the generated concepts. We have totally generated 4 designs. The first design uses spinning wheel mechanism. Here, 2 spinning wheels are used to launch the ball. In the second design, we have used gear mechanism and the elastic rubber is used to launch the ball here. Now coming to the third design. Here, we have used spring mechanism to launch the ball. In the fourth design, we have used robotic arm and claw to launch the ball. Now the question arose that which concept should we select? Thankfully, with the help of the pug chart suggested by our guide, we were able to select a design. So, based on that, we have selected the design 4. Now coming to the virtual implementation. So now I'll be showing you the 3D model of our entire system. This is our first 3D part of the first sprint called the launching unit. This is the figure to support the launcher. This is the box where the servo motor is placed, and this servo motor makes this arm move 115 degrees clockwise, and when this arm moves 115 degrees, the claw present over here will hit the ball and the ball will be launched. This is our second 3D part or the second sprint called the holder. The balls will be loaded through here and the balls will go down and gets collected over here. This structure prevents the ball from falling down. So the claw will hit the ball through this space and the ball will be launched. This is our final assembled 3D model. Once the ball is sensed, the servo motor will make this robotic arm move 115 degrees, and this claw will hit the ball and the ball will be launched at our desired angle. Once the ball is launched, this robotic arm will come back to its original position. The claw is structured such a way that it is smaller than the gap present in this holder.
Circuit diagram of the entire system. Our course project has two subsystem units, launching unit and the sensing unit. In launching unit, we use servo motor. Black one is connected to ground, orange one is connected to digital pin, yellow one is connected to VCC 5 volt. In sensing unit, we use two LEDs and one IR sensor. Blue LED is used to indicate when the machine is on or off. Red LED is used to indicate the insertion of the ball, in which the ball is inserted or not. IR sensor is used to sense the ball. Flowchart of the entire system. As we have two subsystem units, we have two flowcharts. Launching flowchart. Start. Power on. If power is on, ball is placed on the claw. If power is off, the process will stop. If power is on, ball is placed on the claw, then sense the ball. If ball is sensed, LED on, then the process will repeated. If ball is not sensed, the process will stop. Sensing flowchart. Start, LED on. If LED is on, servo motor is on, then ball is launched, LED off, then the arm comes to the original position. If LED is off, the process will stop. Bill of materials required for the entire system. Bill of materials for the ball holder. Parts are ball container, microcontroller, IR sensor, breadboard, LEDs, resistors. Ball container is made up of acrylic sheet with description high quality and the thickness of 5 mm. Its fabrication is cutting. Microcontroller we used is Arduino Mega 2560. Bill of materials for claw. Parts are arm structure, servo motor, microcontroller, breadboard, battery, nuts, bolts. Arm structure is made up of acrylic sheet. Servo motor we used is MG996R servo motor. Microcontroller is Arduino Mega 2560. And the nuts and bolts we used are steel nuts and bolts.
So next we have is motor sizing and battery sizing of the entire system. Since in our project we have only one motor, we will not be focusing on the motor sizing. So here we have battery sizing. The first line indicates the units, which are time, load current and number of motors, which are 3, 1 and 1 respectively. These are the following formulas which we have used, that is time, which is battery by load current, battery which is equal to time into load current, and hence we obtain battery as 3 amps hour. Battery required is equal to battery into number of motor. Hence finally we obtain that the battery required is 3 amp hour. Next in our project we have functional specifications of the entire system. This is a very important portion of the project. Here are the list of functions with its dedicated specifications, like insertion of the ball, in which the container holds the ping pong ball of diameter 40 mm. Carrying of the balls, which is done by passage, which carries the ball. Holding is done by claw, which should be the size such that it should exactly hold 40 mm balls only. Launching of the ball takes place by the servo, which is programmed to rotate at an angle of 110 degrees. Frequency is set to 1 ball every 5 seconds. Reloading takes place once the ball is launched from the launcher. Indication include LED alerts when the machine is on or off, and also when the ball is ready to launch. Next, we were told to simulate our project on Tinkercad. So here we proceed.
Ma'am, this is our final circuit diagram with LEDs, servo, IR sensor and the UNO board. This is the code. Ma'am, over here the green LED is for indication of whether the machine is on or off, and the red LED will be showing when the ball is ready to launch. So when I click on start simulation, as we can see, the green light will be on. This indicates that the machine is on. And on serial monitor, please insert the ball is displayed. If we press 0, that means the ball is not detected, so it returns the message, please insert the ball. And if we enter 1, then as per the program the LED should be on and the servo should rotate. So when I press enter, the LED is turned on and the servo rotates. Now if I press 0, again the message is displayed. If I press 1 and I press enter, the LED turns on, servo rotates, and LED is off. Now, when I press stop simulation, the green light switches off.
With this, we end our presentation. Thank you and have a nice day.